Okay, getting towards the end of our introduction. So we've identified that we have to change x and y to real values, in this case time and height. We've identified that we can then use the information from the question to come up with a formula. So in this case a equals 5 and b equals 6. Okay, then we've identified that we do have a domain of values. Okay, so in this case 0 to t, it is saying that the plant is only growing at a constant rate for 10 weeks, then it stops doing something constant. Okay. And now we have to look at how to use that stuff. So let's have a read here. 3 important features of a linear model h equals 5 plus 6t, which we worked through before, for that range should be noted. Okay, so feature values. H-intercept gives the height of the plant at the start. That is its height when t equals 0, and it was 5 centimetres. The slope of the graph gives the growth rate. Plant grows at a rate of 6 centimetres a week, so that was our B. Okay, and each week the plant increases by 6 centimetres. That's what it's saying. Okay, and I think we kind of got that. The graph is only plotted from 0 to 10 on the time axis. Okay, and they've said because it's only valid for the time when the plant is growing at a constant rate. Okay. And there might be all sorts of scenarios where that happens. If we think back to using petrol, it might be constant on the freeway, but then we get to a hilly section and it changes, so you might have to modify things. So that's actually quite important. That tells you when your data that you're looking at is actually usable. Okay. Once it changes from that, you might need to use it in a different kind of function or whatnot, and if you're doing higher maths, you might use that, but we're not interested. So let's have a look at what it says. The next thing we need to do is to be able to use that model. In this case, we're using it to make a prediction. Okay? So to use a mathematical model to make predictions, we simply substitute a value of t into the model and evaluate it. Okay? So, of course, our model is in the form of, I'll write it down here, my whiteboard, h equals 5 plus 6t. Okay? That's our formula we've worked with our plant growth at the moment. Okay. We simply substitute a value of t into the model and evaluate it. Okay. So we know this is only really valid between 10 and 0 weeks. So in this case, they're asking, for example, how high is my tomato plant going to be after 8 weeks? Okay. After 8 weeks growth, T8, the model predicts the height of the plant to be h equals 5 plus 6 times 8, which is 53. All they've done is put 8 weeks in there instead of the t. Okay. The value could also be read directly from the graph. If you've graphed it, and if it's on your CAS, you can move your cursor along here till you find your 8 weeks, and then it'll tell you what the height's going to be. Okay. Any point along this line is going to tell you how many weeks and how high it's going to be. Any point. Okay. Has to be on that line though. Not up here somewhere, not down there somewhere, on that line. Okay. Let's try it ourselves. So let's say we want to know how high it's going to be after 10 weeks. Okay. So that means it's full growth essentially, and it's just doing a little bit differently after that. So at 10 weeks, so at 10 weeks, t equals 10. Okay, that's the hardest bit we've got to do. Identify what variable we have to substitute for. Okay, so in this case, we stick t into our equation. So let's see what that looks like. H equals 5 plus 6, 10. Okay, I'll put the 10 in brackets. It's an easy way of saying multiply. You could also put a multiply by 10 there if you like. Okay, so H equals 5 plus 60 equals 65. Okay, we talked about that in the last one. One thing we also have to do, or be able to do, is to swap it around. Okay, so I might say I want to know when my plant is going to reach 80 centimetres. Okay, Because at 80 centimetres, I've then got to go and string out another line, and I don't want to drive all the way over to my tomato plants, which are in a different suburb and under lockdown. Okay, so I need to know when I should go, so I don't have to drive all the time. So that's a scenario. Probably only valid at the moment, but let's see what that means. So at this time, I'm going to say, I'll put it in black. So when my H equals 80 centimetres, okay, so I have H equals 5 plus 6t, and I want to find out what t is. Okay, I want to decide when I've got to go over and do all the work on my garden. So let's write that out. So 80 equals 5 plus 6 times t. Okay, we've got to rearrange all this. So firstly, before we rearrange, remember you have a handy little function on your CAS, and it is something like solve 80 equals 5 plus 6 times t, comma, we're going to solve it for t. Okay, you stick that in your CAS and you'll come up with an answer, t equals something or other. Okay, we're going to do it the mathematically way, so you have the opportunity to do both ways, because sometimes it might be a bit quicker to do it either way. So remember, I'll start from scratch, 85 plus 6 times t. So my 5 goes over there with a minus, so 80 minus 5 equals 6 times t. So I just rewrite that one, 75 equals 6 times t. My 6 goes over there with a divide, so 75 divided by 6 equals my t. Sometimes you can, if you get really good with this stuff, there's only the 2 operations to swap most of these around and you're done. Okay, so I'll just rearrange that, do the calculation. I'm not quite sure what 75 divided by 6 is, so I'm going to use my CAS. And it comes up with 12.5. So after 12.5 weeks, I'm going to have to go and work on my tomato plants. Having said that, we have noticed that that time is outside of my useful range, so I might have already been there at 10 weeks time off. Okay, so we need to know both those ways. We need to know how to predict values, and my next one is going to be going through one of the questions on 6G1, my next video.